Is it possible to replace motorcycle components in your home using a 3D printer? Today on Spence Lab, let's find out. It's the middle of a particularly cold winter here in Toronto. The roads are covered in snow. It's not exactly an ideal time to be out riding motorcycles or doing any kind of fun thing, so better time to go down and do some maintenance. One of the things I need to do, usually every year, when I put my motorcycle into storage, is to put fuel stabilizer into the tank and run it through, as well as take the battery out to charge. It's an older motorcycle with carburetors, and it ends up sitting usually for about 6 months, sometimes a little less than that, but I don't want to take any chance that the carbs get gummed up with fuel deposits, so putting a little bit of fuel stabilizer in the tank is excellent preventative maintenance to keep the bike from having an issue in the spring when I want to get the thing started. And usually when I do this, I'll run it for a while just to make sure that the stabilizer gets fully run from the tank into the carburetors. Stupidly, I let the bike sit for a little too long, and so now the battery is dead, doesn't have enough juice to get started, so I'm going to have to boost it with my car. Luckily, I keep a set of jumper cables at the ready. While the bike was warming up, I started thinking, I wonder if there's something I could solve on this bike that's bothered me since I first got it. Originally, this motorcycle came with a fairing piece that would actually cover the side stand, making it a more aerodynamic package when the side stand was up. Now, most of these unfortunately get kicked off or lost pretty early on in the bike's life, and they're very expensive to replace as it's an OEM part that's no longer manufactured. I did a quick search online and ended up finding that someone had already scanned and produced an exact replica of the part. Could this be printed on my 3D printer? Well, I guess it's probably the only way to find out. Once I had the file loaded, I brought it into Bamboo Studio, where I was able to orient the part in what I thought would be the best case scenario for being able to print it in its strongest state and adjusted some of the settings for thickness of material. Then I just hit print. Pretty amazing to watch the first layers get set up on the build sheet. Printer works slowly at this point, and it seems like it might take forever, but this is just a really important layer to initially get the structure. Once the print gets going, it moves at a much faster pace. And you can see the structure that gets built as well while it's printing. Now this structure will support this component as it gets built so that it doesn't tip or warp. And it's just a very thin layer of material. It's pretty amazing to watch this thing work. It's been very, very stable so far through this whole print process. Now that we get to the final few layers, you can really see this part is starting to take shape. Again, I'm amazed. With the print complete, it's time for me to take a peek inside and see what we made. Looks pretty good. I've given the print about 15 minutes to cool, just to make sure that I don't have any issues with warping. It's important to let it set for a bit, just to make sure that the plastic's fully hardened. And I've printed this in PETG, which is still a reasonably inexpensive filament material, but just a bit more robust than PLA, which is kind of the standard basic material you use for these printers. PETG should provide with just a little bit more strength and a bit more resistance to moisture and temperature change. Given that the part's going to be used on a vehicle outdoors, I'd rather not take the chance of using something that's not going to be durable enough. Looks pretty good. All this structure here, you can see the support will just basically snap off as it's very lightly stuck to the material. It's basically designed just to hold on there. So it comes off with little effort. Just have to be gentle to make sure I don't damage the part while I'm removing it. A little bit of follow-up cleanup on the part, just to make sure that we've got all the little tiny bits of additional support or residual material on the base cleaned off. And that way we can kind of take a look at what the final part will look like. And I mean, amazingly, it looks phenomenal. Considering this is just a raw part, no paint, no surfacing. I may do that at a later point in time, but for now, I just want to see if this part's going to work on the bike. I really got to say, I'm amazed with how well the part turned out. And I was curious, the bosses that you see on the backside here, they seem to have what looks like threads in them, just like the original part would have. And I was kind of shocked. I didn't think it'd be the case, but I guess whoever scanned it either built the threads into the design. It's unlikely that the scanner picked it up. So I wanted to test and see if hardware that looked like it'd be the right size would actually fit and thread in. And sure enough, amazingly, this M4 hardware threaded right in. It's pretty impressive, to be honest with you, the fidelity to be able to print something that has built-in threads that right out of the printer you can just screw existing hardware into. I really didn't expect that. That was quite surprising to me. So I figured if it's got threads, might as well just try mounting it onto the bike. I brought it down and I just, with my Allen key, put some hardware in and mounted it to the existing bosses on the bike. And it seemed to be well aligned. I mean, at least the scale of the part has come out perfectly, so glad that I didn't have to make any adjustments after the print. I'm just testing it out here, and it's a little bit loose. I'm not exactly thrilled with that plastic thread. I'm not surprised. I mean, metal into plastic thread, this didn't really strike me as the strongest setup, so you know, here I am just sort of testing it, and already it's getting a little bit loose just from, you know, a little bit of back and forth action. So I think I'm going to take it out, and I have a solution I'd like to try for this. I think it'll be a little bit more robust. So here's the solution, some threaded heat inserts. I've identified the size that should be a good fit for it. And what I'm doing right here, I just want to double check and make sure that that hardware that I planned on using is going to thread into it. You know, I mean, it's one thing to install a part first, but without testing it, just in case, you wouldn't want to have inserted that part to find out that ultimately you set up the wrong hardware. So I want to just make sure that these guys are going to set into the holes that are existing, and it doesn't look like it's going to be a good fit. So what I've done is I've found a drill bit that's close to the same diameter, and I want to just pre-drill these holes because I don't need the plastic threads that were pre-existing in this setup. And that way I should be able to put the insert in without any major effort. Okay, the holes are drilled, and now I just want to deburr the edges just so that there's no plastic swarf that's built up on the edges that could impede the part from fitting into that hole. And they look pretty good. Let's test and fit. It's still a little bit too snug. So I want to go just one more size up, just incrementally adjusting on that bit size. Don't try this at home, kids. I'm being pretty cautious with the drill, but it's probably not the best way to do this with the bit right with my hand underneath it. But I'm being pretty gentle with it and just opening the hole up lightly. So I'm going to clear out that swarf again that's just sort of built up from the bit. And I want to see now if that's going to sit in a bit better. And it seems to sit nicely. And that's just going to make this insertion process just a little bit smoother. Should also check the outer hole just to be safe too. Yep, looks good. So I've got my vise set up just as a surface to get in here, and I've got my insert in, and now I'm going to use a soldering iron with a little insert tip that's designed to conduct the heat through into this brass insert. And what it does is I basically just set the iron to the melting point of PETG, the material I printed this out of, and it will slowly heat and allow me to press the threaded insert into the part. I'm just doing it very gently. I don't want to force this. And then I've, at the very last second, just stopped a bit early because what I want to do is use the surface of the vise to push the rest of the insert in flush. That's a trick I've seen online. Just makes for a nice clean finish and no risk of it, you know, going in on a weird angle. So we'll do the same for the other side. This is why you can see it's nice to have that hole pre-drilled. And again, just going to very gently glide this part in. It's really satisfying to do. These heat inserts make such a big difference because when you're doing 3D printed components, while the part is usually quite strong for general purposes like this, the mounting points are usually the weak point. So in this case, I'm just reinforcing it with this brass insert. So I'm able to get those inserts pushed in nicely. And boy, it's really starting to look like a professionally made part. So now I just want to test to see that the hardware threads in nicely. And it's even better than the original plastic threads. This is really turning into quite a nice project. You know, the only thing I'm thinking is, I think these hardware, while they're a nice brass match to the insert, the heads are a bit small, and I think I've got something better for it. So these are a nice Phillips head bolt that should be the same thread pitch, and it is. And I like them for two reasons. It's a larger bolt head, which will give me a little bit more surface area at the mount. And it's also a Phillips head. And while I really enjoy using Allen keys for most jobs, because the motorcycle has a Phillips head in the spare toolkit with the bike, it kind of makes more sense to keep the components in the line of the same type so that if I need to do roadside maintenance, it's kind of good to go. So let's test fit this and see how it's turned out. Once again, I know the holes will line up because we've already done that with the plastic threads. But now I can really put some good torque on these brass threads, and I think it's going to make for a much more robust hold on the part, which is what you want, given this is a side stand. It's going to be kicked out. It might not be delicate every time I'm using it. You know, it's going to be potentially bouncing up and down if the motorcycle's going over rough terrain and things like that on the road. So I don't want to lose this part that I put this time into making, so it's probably worth just having it be a little bit tighter on there. So snug it all up. Feels so much better than before. And the only thing left to do is give it a couple of test kicks and just see if it really ends up being as tight as I'd like it to be on there. Much better. I mean, night and day to compared to what it was when I first mounted it on there. And so there it is. All done. Project finished. I gotta say, I'm really happy with how this whole thing turned out. That little P2S is very useful so far. It's starting to pay for itself. So if you like the video and you'd like to see me try more projects, maybe see what else I can do with this thing, it'd be great to have you come along for the journey. So don't forget to like, share, and subscribe, and we'll be back soon with another project on the 3D printer at Spence Lab.